In this video, we're going to find the compositions of the two rational functions and their respective domains. Remember, the reason for this channel is to help you pass your math class so you can reach your goals and get a better life. Composition of rational functions, coming right up. The first problem I want to work on is to find the composition f composed with g of x. So that means g is closest to x, so I'm going to feed g in to f. So let me just change the color here. So this is going to feed g everywhere I see x in f. I'm going to be feeding g into it. So that means I have f, and let me just change the color one last time. So g, what g looks like then is 1 all over 1 plus 3x. So everywhere I see x in f, that's what I need to put. I need to put 1 plus 1 over 3x. So f is 1 minus x. But of course, instead of x, we're going to use 1 all over 1 plus 3x. I'm just going to put parentheses around the denominator there. So that's the equivalent of 1 minus x for the numerator in f. Now the denominator of f is 3, and then instead of x, I have 1 divided by 1 minus 3x. So that's 1 all over 1 plus 3x. I said minus, but I meant plus there. Now I've got to get all of this over a common denominator. So in the top there, instead of 1, I'm going to have 1 plus 3x all over 1 plus 3x, because I've got to get it over the common denominator. So this is just for the top. I'm not doing the bottom yet. Minus 1 all over the same denominator, 1 plus 3x. So that's just the top. And now for the bottom, I have 3 all over the denominator, 1 plus 3x. Let me just put parentheses around that, and let's simplify that. So we have 1 plus 3x minus 1 all over the denominator, 1 plus 3x. For the top, and in the bottom, we have 3 all over the denominator, 1 plus 3x. And of course, this is going to add up to be 0, because 1 and minus 1 are 0. When we simplify, we're going to get in the top 3 over 1 plus 3x. Then we're going to multiply by the reciprocal, because that's what we do with complex fractions. 1 plus, oh, that's a 3x. Plus 3x here, divided by 3. And I see that this and this together will be a factor of 1. This and this together will be a factor of 1. So what I end up with is x. So I've just found then that f composed with g of x is just x. To find the domain, I need to find the domain of the result of f composed with g, and I also need to find the domain of g and then take the intersection. So the domain of g, well, we're going to have to eliminate anything that makes the denominator 0. So the domain of g must exclude minus 1/3. So the domain of g is negative infinity up to negative 1/3, since that's what makes the denominator 0. Union, remember, union stands for a gap, negative 1/3 up to positive infinity. Now the domain of the result, the domain of just x, is all real numbers, And the intersection of these two is just going to be the domain of G. So the domain of f composed with G is just the domain of G. So it's negative infinity up to negative 1/3 union negative 1/3 up to positive infinity. To save time, I've got to start it here. For G composed with F, we feed F into G, and we replace X in G with the result of F. So this is going to give us 1 all divided by, well, I've got to get the common denominator now. So I'm going to have 3x all over 3x plus 3 minus 3x all over 3x. So I need to simplify that next. So we'll want to simplify this. We've already got it over the common denominator. So this is 1, and now in the bottom you'll notice we have 3x plus 3 minus 3x all over the common denominator, which is 3x. In the top here, this is going to add up to be 0, so we'll have 1 all over 3 divided by 3x, and I see that this is going to factor out to be 1. So I'll have 1 all over 1 divided by x. You've got to be really careful here. Next, I'll have to multiply by the reciprocal. So of course when we multiply by the reciprocal, we get 1 times x over 1, so that just equals x. So we just found that G composed with f of x is x. So in order to find the domain of G composed with f, I'm going to have to find the domain of f and the domain of the result. So the domain of f, well, the only thing that's going to be a problem there is if x equals 0. So the domain of f is all real numbers except for 0. So negative infinity up to 0 with a gap, that's the union symbol. The domain of just x, well, that's all real numbers. And when I take the intersection of all real numbers with the domain of f, that's how I find the domain of G composed with f. And that is simply the same as the domain of f because that's what the intersection is. But remember, that's what you're finding here, the intersection of the result with the domain of what you're feeding in. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.